Hi, my name's Gary Taylor, and in this video, I'm going to show you MassTransit's consumer. Now, if you've been following along with previous videos, and I highly recommend that you do, there's not a great deal I need to show you here because we've already gone through a couple of consumers. We've already produced some work and tried to show us how to set up consumers producers with, apps and things like that. So this hopefully is going to be a quick one, but I do want to cover some of the aspects of a consumer that we can forget about or not understand. And there are different ways in which consumers can be created. So I just want to go through a little bit of that in this video. Now, before we dig in, I just also want to let you know that I'm by no means a major expert on this. Yes, we're using this in large projects in production. A few £1 million companies are using this, and we don't have any problems. We are able to use it really well, but it is a big package, and this is a big topic. So what I want to do here is just have a bit of a play. Let's have a look at a consumer and let's see what it does. Right, so we've headed over to Mass Transit's website, the consumer section, and we can see that we have an interface of iConsumer, which takes a message in, and messages are type class. So they say below that your reference types and interfaces are supported, and you can pass them as messages. That's something that's really concreted throughout the documentation, is to try and use interfaced classes, try and make sure that data that's being transposed across is just flat data transfer objects, nothing major to them. So that's the skeleton of how a class looks, or a consumer would look. And this is how you can construct one. Uh, the guts of this really is the fact that there's one method which consumes the message here. Now, this has been made a little bit more complicated than I think it should be for someone who's brand new. What we're doing is, in a consumer, we're also raising a message, but ignore that code. Just consider that in here we've got a context, and that is of type submit order. That means whatever that interface is, whatever methods, properties exist on that interface, then that's the properties that are going to be available on that concrete object as it goes into this scope. In other words, if there's one that says first name and surname, then first name and surname are going to be in here and you'll be able to use them. So this is submit order. So you would expect an order ID, products, the customer ID, something that allows you to complete this order. What you really should do is you should pass in everything that this particular function needs to do its job. And its job is to submit an order off. Now, once it's done that, it might need to raise the fact that it's done it. And that's what this is. It's raising the fact that it's published that order. It's taken in an order. Someone's requested that an order be completed. It's completed the order. And now it's going to raise the fact that it's done. So if anyone needs to handle stock take or let the customer know that the order's gone through, that will be done in that consumer. Personally, if I was writing the documentation, I wouldn't have put that in there, or I would have put a bit of boilerplate code in that said, processing the order, just to make it easier. Now, it depends on the way that you've got your transport layer up, and that means what type of system you're using, like RabbitMQ or Kafka or whatever. Um, you can have this principle where the consumer is always connected to Rabbit, always waiting, always active and eager and willing to consume that message. So if you have something that's changing a customer's password, you want that to be pretty quick because users generally change the password, log out, and then log back in again. Don't know why, it's just what they do. And if you have a queue that's sat waiting to be polled every hour, then that customer is not going to be able to log in with their new password. With this, the actual consumers are constantly connected. And there's this don't call us, we'll call you principle. The consumers are going to be accessing this system. So what I mean by that is the consumers will be accessing RabbitMQ constantly. And when a producer pushes a message up into it, it'll instantly go through to the consumer. So here's an example of configuring a consumer. There's a lot of boilerplate code here, unfortunately. You know, it's .NET, so you've got the namespace, you've got the packages that you want to include, you've got the program, you've got the main. So all of this is just nonsense so far. Then you get into the meat of the work, and that is to configure the bus. These things are never easy in production. It's never that simple, but they tend to be something that you configure and do once and then just reuse. You know, it's a bit like your startup code that you have or your bootstrap code. Once you've written that, you're done. You don't need to write it again. And it's same with creating the service buses. You're going to create a bus that connects to Rabbit. You're going to configure it. You're going to set the host, the password. You're going to set timeouts. You're going to do lots of stuff that we'll get into later on. But for now, we are just creating a bus that allows us to configure and connect. Sorry, we're creating a bus that allows us to connect to Rabbit. Once we've configured it, we can configure an endpoint. And we can say, I want a particular endpoint called order service. And when a message is dropped into that order service exchange, I want you to send it through to the submit order consumer. So there's two great big points here. The exchange that you're interested in connecting to, and then the consumer that you want to register to that exchange. Now, under the hood, with RabbitMQ, there are these topologies or configurations or default ways in which MassTransit does something. And you just got to get used to their terminology and the wording and the way that they explain this. And what they're saying is that the topology for this would be I will actually set up an exchange, a queue, and the binding automatically. I'll just do it all for you. Because under the hood, when you're doing this, this is the topology of a consumer. This is how it's going to be configured. Now you can adjust that, you can change that, you can radically provide a different topology, or you can use the happy defaults that come with MassTransit. Now, when you're new, I highly recommend just sticking with the happy defaults until you get to learn it a bit more. Skipped messages. If the consumer's not able to process that message, then it's skipped. I'll show you more of that in an example because I had a real problem getting that to work. The idea is that if there's no consumers subscribed to that queue, then it'll be sent to a skipped message. Instead of it just staying there, it'll actually go into a different queue with the name of the queue underscore skipped. And you might see this with underscore error or underscore failed. There's this convention of moving messages out of the worker bucket or the worker queue and moving them into a separate holding area. So it's blatantly obvious which messages have failed or what's had problems, and a human being can go and reseed them back into the appropriate queue or fix the particular problem. And there's toolings to help you. I think there's one called Shuffle that can help you with that, but off topic. Consumer factories. There are multiple ways to configure a consumer. So if we look at this here, this is really easy way of configuring a consumer. You have the or exchange event, and here you have your consumer. So I think that would be the E would be like a MassTransit configure endpoint, and you get that, and you can register a consumer. So actually, here there's a lot of great what do they call them again? Like custom topology that happens. Although we're only specifying an object or a type, we're not actually specifying the object. So I'll correct that. We're specifying the type of class that's going to be constructed. Now, what MassTransit will do is when a message comes into this service and it finds its way into the queuing process, it'll automatically create and register a new instance of this type. And then it'll run the method and pass the message to it. Once it's done, it'll close all that down. And all of that is done just with this one liner, which is really cool. It's the power of these frameworks, but it's also the problem with these frameworks because you've got to be aware that that's what's happening. And with everything, that might not be the appropriate thing that you want to do. Maybe you need to pass in some properties. Maybe you need to only have one instance and keep the same instance for some particular reason. We don't know what your business needs, only you do, and you're only going to know once you're halfway through a sprint. So these libraries have to be really flexible and dynamic in the way that we work. So that's where we have, the MassTransit, has a consumer factory. And here there's loads of different ways of actually setting up the consumers. We can create a new instance explicitly and delegate that to the customer factory. We can actually allow us to create a new instance and use things like dependency injection to automatically pass in things that are needed. Or we can activate a certain type and use the activator to create class, or create instance, sorry, which is just Microsoft code as far as I can remember. And that'll create an instance of that type and pass that through. But you can have specialized usage there that you can wrap it in. Between these types of constructors and the one that you saw above, and I'm pointing with my finger for some reason, between these you've got a lot of power there to create a consumer that works it the way you want it to, that does what you want it to do. So, here we have one that's got a constructor, but it's got a dependency. It's got this text writer. So that needs to be passed in. That value needs to be submitted across. Well, you couldn't do that with just the traditional typed consumer delegation. You would have to have some way of being able to construct that. And especially if you really need to pass dependencies down a chain, then you'd need to have that. The final one that we're coming into is temporary consumers. So things that are not forever, they need to be set up. They set up all of their endpoints, they set up the consumers, but once they're finished, they'll close down. And I'll show you more about that in a minute. All about custom topologies. So further on down the documentation, we start talking about connected consumers. Obviously, not obviously, when you've connected a consumer and it's configured to the bus, it's very difficult to modify. I mean, they're saying here that it can't be modified. Um, but you can actually use connector methods to actually change the way that consumers that are already registered work. Um, I think this needs like a documentation in its own right to explain what's going on here. So I'm literally not going to cover it in this video. I think I could go on about that for about 3 or 4 hours. So I'm going to stay away from it. It's going to be covered later on anyway in sagas and containers. So I'll just leave it till then. Um, Instance types. I did mention this before actually. Sometimes you do want to reuse the same instance. So here we can see we've created an instance of the submit order consumer. We're going to use it here in the instance type. So every time we get a message that's registered to this type, it will be processed by this same instance. Now, of course, we all know that that means it needs to be thread safe. We need to make sure that whatever code we're writing is fit for purpose and understands the uh, risks and requirements when you're writing thread safe code. So just be very careful. I can't for the life of me actually think of a realistic reason why you would want to do it. If you want to keep state, then there are other ways of doing it. So as we'll go through the documentation, maybe that'll come to life. There is a habit of being able to understand something once we move to the next page. So hopefully that's what will happen. And finally, I think it's finally, yeah, finally we hit the handlers. This is where we can write anonymous types or anonymous methods that can be registered as a consumer. So this is all about consumers still. So we're able to, instead of providing a concrete class type, we can actually just write a method. Now they go on to say about scope and that there is no scope, so there's nothing to be disposed of or thrown away. But bear in mind, you still do have scope between the brackets. So whatever you create there, make sure that you can dispose of it correctly. And realistically, I can't see a reason for using lambda methods or delegates or anonymous methods to do this because have a class. They say it's great for unit testing. It, he knows better than I do, but for me, I would rather have a concrete class that I can test, hit, and use the testing framework, which we'll get into later on, which is really great. So I personally would never use that. Okay, so let's dive to the top, straight up to the top, and let's have a look at this consumer and let's see what I've got. So I'm not going to reinvent the wheel. I've already built like a lot of consumers and producers in the previous examples. So I'm just going to recap on this and just show you. We have a bus that we're configuring, but the only real bit of code here for registering the consumer is that and that. What exchange do you want to connect to and what consumer do you want to subscribe to that exchange? And under the hood, we're going to set up all of the topology and all of the values that are needed. So if I look at RabbitMQ that I've got set up just using using Docker, um, got exchanges that's empty. We've got queues that are empty. Okay, so if I dive over to some code here, using the previous examples, which had this value enter type mechanism, I've got a consumer that's going to take a type of value entered or value enter. And that's going to feed through to this consume method. Just like what we saw in the examples here, there's the requirement for this interface to have this consume that returns a task that takes the message of the type T. So that's what it ends up looking like. Now here they've got this publish message. I think that confuses things. So if we just look at mine, what I'm doing is I'm just running an async task because we've got to await this. And I'm just writing the message out to the console. And I'm taking the context, message, and value entered. Now context has lots of other properties and MassTransit goodness like the message ID, correlation ID, conversation ID, blah, 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 blah. Quite a few really good values. The most important one at the moment is the message type because that determines the data that we've submitted to this consumer. So here we can see message and I've only got value. It's a really, really primitive interface. So if we look at it, we can see value entered, it just has value. Okay, so that is a consumer. Now up at the top is loads of boilerplate code. We're connecting to the endpoint. We're explicitly stating what the name of the exchange is, and then that is the almighty bit there. That's the bit that registers the consumer, and we are just using its non-instantiated type, which means that when we get a message that comes in, it's going to create a new instance of this type, call this method, and then throw it away. So I'm just going to run that .NET run. Now, as that fires up, if we have a look at Rabbit, we can see that not a great deal's happening. Sometimes it takes a while to connect. So yeah, there we go. It's connected. And we've created this events contract value enter. Now, I really like that syntax of the namespace and the interface type. I just think that is really powerful because it allows us to document things within the contracts, the interfaces, and it allows us to see what they are. and it stops us having naming collisions and problems. And there's a queue being set up here, which I didn't expect. And if we go into it, there's binding set up. Okay, so if I then go to a producer, now we're going to talk about more about producers in the next video, but consumers are a little bit pointless without a consumer to send something to them. And trying to use the console to send messages is really hard because the messages have to look a certain way. So if I just say hello, I can see now that my value has come through. Value enter consumer has been hit with the message hello. So goodbye. You can see now that goodbye came through. So these are two completely separate applications. They could be running on different sides of the world. And we have a consumer that's been registered using a really, really simple way. And it just has everything set up. Everything's working. The exchange was set up with this name. The consumer was registered here. The queue was created and the binding was created. So to explain that, you have an exchange, like you might say a post exchange or a telephone exchange. Their job is to delegate the messages to the appropriate place. Used to have an operator years ago, before my time, by the way, that you would phone up, and as you picked up the phone, they would ask you where you wanted to be exchanged to, and they would take you to the Boston Exchange, and then you would actually be able to get hold of someone and speak to them on the phone. Um, Telephones and routers and networks kind of still work the same. In exchanges, delegate where these messages need to go, but it's based off rules. So we have a look at this. We can, and this exchange could be called anything. We could have called it XXX if we wanted to. But we're saying that from this exchange, we are actually going to bind to these queues. And the message is going to come from this exchange into this queue. And if we then have a look, we can have a look at the queue. And we can see the value there. And if we look at the binding, we can see, yeah, there's the binding here from that exchange into this queue. So that is what that's doing, is it allows us to choose how messages are delegated and to what queues messages are delegated to. We can choose to delegate messages to multiple queues or to round robin or do some kind of business logic. We control where the messages go, but there's a topology, a default set of rules that are configured within MassTransit that does this by default. And this is what you get out of the box, which works and is good. So it's a win-win. Okay, so the next thing I want to look at is skipped messages. So we're saying here that when a consumer is removed or disconnected from a receiving endpoint, a message type is removed from a consumer. If a message is mistakenly sent to a receiving endpoint, messages may be delivered to the receiving endpoint that do not have a consumer. If this occurs, the unconsumed message is moved to an underscore skipped queue. So it's saying that whenever a consumer isn't there, not connected, not up and running, then it's going to go to a skipped message queue. So let's have a bit of a play about with that and try and find out what they mean by that. So if I look at the publisher, what I'm going to do is I'm just going to fire this up, .NET build, just to make sure, .NET run. And I've cleared my exchange down, which I'll show you now. So if I have a look, everything should be back to its default settings. Yep, it is. So let's just run that. And this is the producer. Now there's no consumer running. So if I say hello world and just run that, that'll go out, but there's no consumer. And we got value entered, exchange, with no binding and no queue and no skipped queue. So it was saying that when a consumer is removed or disconnected, now we never even had one running, that the message is removed from consumer, or if a message is mistakenly sent, blah, 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 then it'll be pushed into a skipped. Well, that didn't happen. So let's say hello to. Let's go to the queue. There is no underscore skipped. So I don't really understand what he means by if you disconnect. So let's try and connect the consumer, shall we? Let's make sure it's built. .NET run. I want to alias that for DN. So we're running a consumer. Hello 3. Hello 3. So that message gets processed. Okay, let's disconnect the consumer now, because they were saying when the consumer is disconnected, is removed or disconnected from a receiving endpoint, a message is type is removed from a consumer, or if a message. So these all feel like ors, not ands or some other weird logic. So now when I send another message, it should go into skipped, and I don't think it will. So obviously it's not going to the consumer because it ain't running, so that would be magical. If we go to the queue, have we got a skipped queue? Nope, we don't. In fact, we've got the message sat in the standard queue, not gone to a skipped queue, because actually the binding is set up correctly. So event contract is set up to go to that queue is configured. So the message is just going to go through to the queue and probably get processed when the consumer fires up again. So let's try that, shall we? Let's fire the consumer up. There we go, there's a hello 4 message, and the queue will be taken down now. So that kind of makes sense. Things are going in and getting held there whilst the consumer is not active. You don't really want things being pushed over to a skipped queue, because then you've got to actually do some work by hand, and who wants to do that? So what do they mean? So we created one, didn't work. We then connected one and disconnected it. That didn't work. But one thing I did realize as I was playing about with it is if I go to the consumer, I believe it is, so that's the publisher, this is the consumer. If I change the consumer type and I say that the interface that I'm listening to here is going to be value entered ed, past tense, converting it to an event, more of a sort of send, and I run that, well, there's no consumer now actually registered for that type. So if I say a hello 4, then it shouldn't go here. In fact, that was a bad example. Hello 5. It shouldn't show here because actually this consumer is looking for value entered types, and the type declaration that we sent was value enter, not with the ed. So present tense, or more of an action, not an event. So what happened on the queue then? We got a skipped, because we do have something connected at the moment to that exchange. There is something listening here, and I think you can see it in your channels actually. There is something listening, there is something subscribed, there's a consumer of some sort up and running. However, the message type that you submitted just can't be handled by it. So it ended up going into a skipped. The cool thing about that is we can know that we've messed up somehow. We've raised events that we think a consumer is subscribed to, but it isn't. We've not got the right type. If I go in and look at the messages, I wonder if it actually gives me any more meaningful data. Sometimes you get the headers message body gets added with extra data. So here we've got value entered, value enter. So we can see the contract type and value enter. But there wasn't really an error message wrapped up. It just simply just got redelegated to a different queue. Now, if you had some tools like Shovel installed, some plugins, you'd be able to push that back once you've fixed it. But I don't have Shovel installed on this or anything like that at the moment, so I'd have to just do it by hand. I'm not going to. So let's have a look. So that's how we got this skipped. That's pretty much the only way I could get the skipped queue to appear, was by registering the consumer first, then changing the type of the consumer to a different type than what was published, and then it had a Mickey fit because it's not expecting that particular type to pass down this channel. So let's think about that differently, shall we? Here, and let's think about how we can raise that. So just going to have a bit of a play about now, and what I'm going to do is I'm going to create another consumer, value entered consumer. In fact, let's change that back to value enter, value enter, value enter, call that value enter, and call that value entered as past tense, value entered. So now it will handle both, but actually I don't want to. I want us to do this properly, so I want value enter to be the first thing because that's the action that I want us to implement. But if I run this, it should still just work. Let's see. I always do that. I start writing into code and making a mess of things. Hello 6. Hello 6. Hello 7. So we are sending now a value entered, and I updated the code to understand the value entered interface. So now instead of the messages going to skipped, which I can now delete. Now, obviously in production you wouldn't do that. You would process them messages and work out why they were skipped and reseed them. There is no point having a queuing system if you are not going to work out why you got errors. You might as well just go back to old school monolithic programming and bury your head in the sand. This allows you to work out why things went wrong, so use it. So value entered. If I now go back to the producer, and I'm going to change this to value enter, and that, and build, and run. I never trust .NET Run to actually do the build for me because it feels like it's too quick. But I suppose that's kudos to Core. So hello 7. Oh, not even running. Run. Hello 7. Hello 8. Hello 8. So great. We are now raising the value enter message and getting that into the consumer. And it'll obviously be hitting this value enter consumer. Now, in the example that we got in MassTransit, the very first thing it was doing was of consuming the submit order or value enter, if you squint at it, and then it was publishing an order submitted or value entered event. And I think they talk about more about this in the publisher, in the producer. So we'll cover that in the next video. But for now, what I want to do is take that, copy and paste that. Should never copy and paste code. And I am going to, I don't really know where to put it, to be honest with you. Let's put it here. In fact, that is completely the wrong place to put it. That would be a bit of a problem, I think. Don't know if that would cause an infinite loop, sending a message to the value entered from within the value entered. I don't think that would be a good idea, but I've got my next bit of fun to do. So publish value equals value entered. I did it. I really did it. Okay, pokey. So now when we raise this event, no, sorry. Let me correct that. The producer will publish a value entered. So like some customer going onto a website and clicking, I want to buy this product. This consumer subscribes to that and says, yep, you bought it, you did it, you really did do it. And we process the message. Now, probably you want it underneath, but it kind of doesn't matter. We're just playing. You want to do the work, and once the work's been done, then you can raise the event. Because if any exceptions happen here, they'll be raised up and this won't even ever get run. So the rest of the business logic won't run, which is what you'd expect and what you want. You don't want to send a customer a message or an email or take value out of stock based off something that didn't happen. Okay, so now we publish the value entered, we get it in a consumer, we then publish the fact that we did it, and we should now hit this other consumer. And it just so happens to be that these two consumers live together in the same project. Actually, that might not be the case. There might be something like a stock control system that's on the other side of the world. Maybe you've got China as your distribution system because you're able to get a cheaper rate for on certain products from them. So you use them as a distribution agent for some products. Well, that means that they can be subscribed to this event and they can manage stock take based off that. But there might be someone in Texas or Ohio that is actually better at a certain product and they are subscribed to that. And this allows you to separate systems out. If there's a problem with the stock take system, you don't need to understand the entire ecosystem or the entire monolithic application. You just need to work on that little bit with the message that gets in. So although these two consumers are in the same place, try and imagine that they don't need to be. And in a lot of cases, they won't be because they'll be managed by different departments or different tech teams or even different companies. So let's go back to the drawing board with this. Let's stop this. Let's run it again. It should do a build automatically. I'm just going to stop this as well. Do a build and a run. Okay. Buy chips. So here we've got value enter consumed by chips. And we should have published the message value entered, and that should have gone through to the consumer. But I think I know what I did wrong, and I'm going to give you a couple of seconds to think about it too. Whilst I'm letting you think, I'm going to have a look at value entered skipped. So something was skipped. Well, this is a coincidence. This is something we were just talking about, wasn't it? I did it. I really did it. It got skipped. So we talked about this before. When that event contract hasn't got a consumer subscribed, it'll move it to the skipped queue to let us know, I think you've cocked something up. You've raised this event, but I have no idea what to do with it. Well, why not? I built the consumer, didn't I? Look, what I didn't do was actually register the bloody thing. I built it, but forgot to actually add it to the bus. So let's do that and see if my life's different. Okay, let's see what we win. Let's go again. Buy beer. So we got a value from a consumer to buy beer. We were able to process that message and take payment or do whatever we want. And now we've got that, and that request went through successfully. We were able to raise an event, maybe to our stock take, or maybe to the shop, or maybe to the distribution team to send the beer to them. And that's where we got this value entered consumer. I did it. I really did it. And that might be a request with IDs in there from this original message to process or start packaging this particular um, request. And it's down to your business logic, and it's down to how you define your business. So to build up on this design principle and this design idea, I want to borrow, hopefully with permission, from Pluralsight this slide. It's a course called Designing Event-Driven Applications using Apache Kafka. It's really worth having a watch of this and signing up to Pluralsight just to get access to this course. It's really good. Here we can see a list of things that happen within a stock take system. You know, we add items to a basket, we check if things are in stock, we need to update baskets, send notifications, check addresses, check payments, check approvals. And anyone that's used to Scrum, we're used to creating these tickets and these post-it notes and just saying, right, what do you want the system to do? Well, we want to be able to put things in baskets. We want to be able to store the basket. We want to retrieve the basket, email them with the basket if there's a problem. We need to check their address, check their credit card details, make sure the payment's gone through before we're allowed to approve the actual submitting of the goods that they bought in the basket. We want to send them notifications to let them know that the items have been dispatched, that the card has been accepted, blah, 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 blah. Before you know it, you'll have a huge backlog of feature items. But we need to turn this into something manageable, useful, scalable, and queuing systems with RabbitMQ and MassTransit turn this into something that is fundamentally really easy to do once you've understood the normalization of turning a backlog and a wish list into something a bit more meaningful. So what's happened here is there's been a bit of normalization occurred where we've moved everything into these three tranches, the order, the payment and the shipping. And we found that when we looked at all the post-it notes, they did go into this particular group. We were able to check the order, check the basket. We were able to validate their address, create the user accounts, validate the user account's email address, confirm the payment, validate the credit card, validate the shipping address, and then send that off to a shipping once the payment has been fully accepted by the bank transfer, and that went into shipping. We might even have a stock take system that it goes over, which feeds back into the order system. And we were able to group together all of these items. Now here we could have three exchanges. And in the exchange is all the consumers and the events that are being raised. An order has the ability to push messages onto the payment, and payment has the ability to publish messages to shipping. But there is no real way, traditionally, we want to reduce the way that we actually send messages to shipping. We don't do it directly. Messages from shipping only come from payment because nobody should be able to submit something to shipping without first doing an order, paying for it, and it going through. So ordering platform becomes a window to the soul. It becomes a window to your ecosystem. Customers can only access things through the ordering platform. We can only access things through the ordering platform. We can then work out whether it's been paid or shipped, but we shouldn't really be able to transfer anything past this layer because it ensures that safety and that security, and it ensures the workflow and the business rules are being upheld. So that is a really good way of looking at delegating this, and that's exactly what we just saw with the value enter and value entered as it worked its way through the system. So really the final two consumers that I want to show you is the temporary consumer and the interfaced consumer. Now, I'm not going to run through an example of the interfaced consumer because that's just creating a new class and passing it across, a new consumer type and passing it into the what's it called? Message queue received configurer, something like that. And that's what that E-type is. We can configure the consumer. What I want to do now is look at the way that we can delegate a receiving endpoint. And we can get a temporary endpoint, a temporary exchange, I think, a temporary queue and the temporary bindings and submit messages through. Once you're done, you close it all down and hey presto, everything's cleaned up again. So let's copy and paste this. We should never copy and paste. We should type by hand. And we need to go into the consumer. So let's register a consumer, shall we? Got the configurer. And what I'm going to do is I'm going to move the entered consumer and I'm going to use this temporary endpoint. Now, we talked about the topology and the way that MassTransit has these happy defaults and these happy setups. They also try the best to help you out in stopping you from having to understand what's really happening under the hood. It is a library, it is like a framework, it's here to help you out. You really shouldn't have to understand the inner workings of this. It should hold your hand. After all, that's what managed code and libraries is all about, is it encapsulates complexity. So if we look at the way that we normally register a consumer, and we normally register an endpoint, we can give it just a string value. Now that looks a bit more complex than it needs to. It could just be XXX and it would create the exchange called XXX. I just love this event contract namespace plus the name of the interface as these concrete naming conventions. Makes life a lot easier. But here what we're doing is we're just creating a temporary endpoint. So what does that actually mean? Well, it means that it's going to be configured with some happy defaults. We can create a receiving endpoint, and this is overloaded, I believe. So you can pass in strings, you can pass in configuration, and you can pass in endpoint definition. If we have a look at that, we can pass in temporary endpoint definition, which should implement the I endpoint definition. And this has got some happy defaults configured for us. We can see things like prefetch count, configuration topology, concurrent limit, and there should be something else set here as well, which says whether it's forever or not. I believe there should be a value that says whether this lives forever or it should just be temporary. So I think what's happening here is because I'm using it's like reflection or something to disassemble the code from the DLL. If I actually go to the code itself, we can see on the MassTransit GitHub that if we use a temporary endpoint definition, it uses an iPoint definition interface, so we can pass in that type. But here, we already have some happy defaults. We're able to configure the tag, we're able to configure prefetch types, but the most important thing is temporary is true. So we're going to say that this is a temporary queue. So just by creating an instance of this type, we've got these happy defaults. We don't need to worry about configuring that, which, do you know what, makes our life a little bit easier. Now what I'm going to do is just pause this video, and I'm just going to clean the queues up. So I'll clean things up. There's no connectors now, there's no exchanges apart from the default ones, and there's no queues. So if I go over back to the code, what I've done is I've registered, instead of registering the consumer in the traditional fashion, I've registered using the temporary endpoint definition. So I'm just going to run this. And see what happens. So I want to see what I get by default. So we got the value value entered, and we also got this crazy exchange name, which is, if we actually have a look at the code, you can see it's endpoint plus the unique value, the name of the queue, the name of the app, sorry, name of the server. So you can kind of see it all pasted together. That's the name of my machine. That's the name of the app. That's endpoint and then a random generated value. And if we go into that, we can actually see, I think this is registered to a queue as well. So this exchange is registered to this queue. And if we go into the queue, we can see that we're empty at the moment because we've not submitted anything. And we've got a value enter queue as well. So wow, loads of stuff set up, loads of stuff done. So if I just turn this off, what happens? Well, that random queue name is gone. So is the exchange. So it's cleaned itself up. It said that, this wasn't forever, this was temporary, just as we're up and running. Now, that's great, but you've got to bear in mind, why would you want to do that? Why would you want this to all shut itself down? Because this is the consumer. So what about the producer? If you've still got producers running, trying to send messages, then is that not going to be a problem? So let's fire the consumer up again. And we should see things coming back to life with a new endpoint, with a new queue, and obviously bound. Well, not obviously. Let's make sure. Yeah, bound to the exchange. Should always challenge someone who says obviously or this is a fact, because it never is. Okie dokie, let's have a look at that. Let's run a message. Buy more beer. It helps if you run it. That should be a command, especially on Linux. Buy more beer. Okay. Value, buy more beer, and we got a value entered from the consumer. I did it. I really did do it. So that shows, well, does it? Yeah. What I'm thinking there is, does that prove to you that that went through that exchange, that that message actually was consumed by that consumer? We have the value enter, but look, we don't have a value entered queue. So although we do have a value entered exchange, I actually don't think that convolutes things, in that the only way for the value entered queue to be processed would be for it to go in here. It's the only way. So if I have a look and I just keep on passing things, I do 1, 2, 3, 4, 5, 6, 7, 8, 9, then if I have a look, we should see messages trickling through into this queue, and we do. We see, 4 messages a second, 5 messages a second, and then died as I was typing and typing and typing. And then messages all found their way through into the consumer. And there was a value submitted and the value entered raised, and we can see that that went through into that temporary queue. If we then close things down, we can see now, gone, that queue, lost, done, exchange, cleaned up. So that's a really nice way of making sure that your queues don't fill up with these with these exchanges and queues and bindings that no longer no longer required. I've seen systems where there are thousands and thousands of exchanges that haven't seen a message in months, but nobody on the development team dare delete them because If you delete the exchange, then you have messages that will be lost. And rather than live with that risk, they just keep them. I've seen people who've registered them to a queue which handles the message and generates a message in Slack or Teams or whatever to say, message just jumped into this queue. It's not had one for a very long time. You need to keep control of your exchanges and your queues. You need to manage them. You need to clean them up when they're no longer in use. And that's tricky, isn't it? Because multiple teams, multiple developers, and multiple pieces of business logic, um, that can be difficult to accomplish. Which is why you should always document this type of business logic, where one message will call here, this will be consumed, the value enter will be consumed, that will release a value entered message. So that explains what's going on. Best place to do that is within your documentation, within your interfaces, in my opinion. You can document everything within here to say that, value enter raises a value entered event. And then you have that documented at least somewhere. But there are other ways of documenting that workflow as well, as you saw with the Pluralsight example. Right, so we're coming towards the end of the hour now, and we've done quite a bit of playing. In the next video, we're going to go on to the producer. So we talked about the producer already, but we're going to go into more detail in the next video. So I hope you stick around, hope you subscribe so that you get your notifications when that video drops. Also, if you subscribe, it'll allow me to get closer to that almighty 1,000 subscribers and somehow get some kind of pennies for the videos that I'm doing. So thank you very much in advance. Have a good day.